Okay, so this is the 2021 Ordinary Level Maths Paper 1. Question 1, we have a television. It costs €380. Before VAT at 21% has to be added. Find the cost of the television after VAT has to be added. So the cost of the television is €380 before we add this 21%. So what we've got to do is just simply get 21% of 380 and add it on. So let's do that. So we have 21% of 380. That's going to be 21 over 100 times 380. That's 79.81. So we've just got to add it on then. Take your 380, add on the 79.81. That gives us 459.8. So this is the cost after VAT is added. Okay, part 2. When VAT at 21% is included, the price of the laptop increases by €130.20. Find the total cost of the laptop including VAT. So it increases by 130.2 euros. Now the VAT is 21% now. It was 21% previously. 21%. The 21% is going to be equivalent to the €130.20. So if we take 1%, that's 130.20 divided by 21, and then if we take 100% multiplied by 100, so it's 130.20 divided by 21 multiplied by 100. That'll give us, let's see, 130.2 divided by 21 multiplied by 100. That gives us €620. This is the cost of the laptop before the VAT is added. So the total cost, so that means the total cost is going to be equal to the 620 plus 130.20, and that'll give us €750.2. That's the total cost. That's your answer there. Okay, so the next one then, a printer priced at €290.4 including VAT at 21%. Find how much VAT is included if the price of this printer. So in this particular case, we know that the €290.40 is going to be equivalent to 121%. So it includes the 100%, the price of the original price, I should say, plus the 21%. So we want to find out how much it was before the VAT was added. So let's go to 1% and then up to 100%. That will give us the price before the VAT was added. So to go from 121% down to 1%, we divide by 121. So take the 290.4, divide it by 121, and you will get 2.4. Multiply that by 100 and you get €240. So that means the price before VAT was €240. So that means then that the actual VAT amount is going to be equal to 290.40 minus the 240. That's €50 and 40 cents. So that's how much VAT was actually added to the price of the printer. Okay, so that was part C. Let's have a look at part D. On September the 1st, 2020, the standard rate of VAT in Ireland was reduced from 23% to 21%. A company bought 30 computers in September, all at the same price. The company calculated that it saved €336 due to the reduction in the VAT rate. Find the price of one computer before VAT had been added. Okay, so in this particular case we have our 2%, which is equivalent to the €336. The 2% came from the reduction from 23% to 21%. Now we want the price before VAT of our 30 computers, so I'm going to go down to 1% again, so divide 336 by 2, that gives €168, and then let's go up to 100%, which is the price before VAT, so multiply that by 100, which is €16800. This is the price before VAT of the 30 computers. So that means then that the price of one computer before VAT is just going to be equal to 16,800 divided by 30, and when you do that, let's see, 16800 divided by 30, that gives you €560. €560. And that's it for D and question 1. Let's have a look at the next question then. Question 2, it's a complex numbers type question. So we have Z1 here, which is minus 3 plus 4i, Z2 is 4 plus 3i, I squared is minus 1. Plot and label Z1, Z2 and Z1 plus Z2 on the argon diagram. So let's just add the two complex numbers first. So we have Z1 plus Z2 is equal to minus 3 plus 4i, and we want to add 4 plus 3i. So if we add those two, you just add the real parts and add the imaginary parts. So we have minus 3 plus 4, that'll give me 1 for the real part. Now add the imaginary parts, plus 4i plus 3i, that's plus 7i. So this is Z1 plus Z2, 1 plus 7i. Now you just got to plot these three. So let's see, we have Z1 is minus 3 plus 4i, minus 3 plus 4i is here. So that's Z1. Z2 is 4 plus 3i, so we go out here 4, we go up here, so that's Z2. And then we have Z1 plus Z2, which is 1 plus 7i, so we're going to go out 1, we're going to go up here to 7, so this is Z1 plus Z2. Okay, that's part A. Let's have a look at part B. So in part B here we have Z3 is equal to Z1 divided by Z2. Find Z3 in the form A plus BI, where A and B are integers. So we have Z1 divided by Z2, so let's do that. Z1 divided by Z2, so that's equal to, now Z1 was, let's see, Z1 is minus 3 plus 4i. So we've got minus 3 plus 4i. We've got to divide that by Z2 here. So that should be 2 there. So we're going to divide by Z2. Z2 is 4 plus 3i. So this is 4 plus 3i here. So the way you divide complex numbers is you multiply by, you take the denominator and you just simply get the conjugate of the denominator. In other words, change this sign to a minus and you multiply by that over itself. So it's 4 minus 3i divided by 4 minus 3i. You're just simply multiplying by 1. This is 4 minus 3i divided by 4 minus 3i is just 1. So you're multiplying this by 1, which means you're not changing it. So when you do that, you multiply the top by the top, the bottom by the bottom. So that means you multiply this by this, this by this, this by this, and this by this here. So let's do that. Minus 3 times plus 4, minus 12. Minus 3 times minus 3i is plus 9i. 4i times plus 4, that's plus 16i, and then plus times minus, minus 3 4s 12, and I times I is I squared. That's our top line. Our bottom line here is 4 times 4, which is 16. 4 times minus 3i is minus 12i, plus 3i times plus 4, that's plus 12i, plus times minus, minus 3 3's 9i squared. Now let's do the top line first. Now what I'm going to do here is just look at this here and this here. Now remember, I squared is minus 1, so this here just becomes minus 1. Minus times minus is plus, so this whole thing here just becomes plus 12. So we've got a minus 12 here, we've got a plus 12 here, so that means those two will just cancel each other out. What are we left with then? We're left with 16i plus 9i, that's 25i on the top. Let's have a look at the bottom. Same thing here, look at the I squared first, so I squared is minus 1, so minus minus is plus, this becomes plus 9 here. So we have 16 plus 9, so 16 plus 9 is 25. Now here we have minus 12i plus 12i, so that will give us 0. So this is our answer here. Now you would be expected to simplify this, so the 25 divided by the 25 is just I. So they want it written in the form a plus bi, so I'll just do that. That's just going to be 0 plus 1i, or just 0 plus I. Okay, so that's part B. Let's have a look at part C. Find the modulus of Z1, the conjugate of Z1 minus Z2. So where Z1 is the complex number of is complex conjugate of Z1, give your answer in the form P root Q, where P and Q are natural numbers. So these two lines here just mean that you've got to get the modulus of what's between them. So the modulus just means you get the square root of a squared plus b squared. We'll do that in a second. The little bar on the top of the Z1 just means the conjugate. So what we've got to do is, let's see, we've got to do the conjugate of Z1, and we've got to subtract Z2, and then to find the modulus of our answers. So let's do that. Now let's write all that out. So we've got to get the modulus of the conjugate of Z1. So let's have a look at what Z1 was again. So Z1 up here is minus 3 plus 4i, so we want minus 3 minus 4i. So we want minus 3 minus 4i, that's our conjugate. And now we've got to subtract Z2, so Z2 up here is 4 plus 3i. So we're going to put in 4 plus 3i here. So this is what we've got to do. Now it's a good idea to put these in brackets when you're adding or subtracting these things, particularly when you're subtracting, because this minus is going to change the signs of these two things here. So let's just simplify all of this. We'll take away the brackets now. So we've got minus 3 minus 4i. This becomes minus 4, and this minus times plus is minus 3i. Now we're just going to add these. So let's add the real parts. Minus 3 minus 4. That's minus 7, minus 4i minus 3i, that's minus 7i. So now you've got to do the modulus of this. So the modulus of this is just going to be the square root of the a squared, which is minus 7 squared, plus b squared, which is this minus 7 squared here. So that will give us minus 7 squared is 49, minus 7 squared is 49, 49 plus 49, so that's going to be 98, and they want this in the form P root Q, where P and Q are natural numbers. Now you can just simply type this into your calculator, type in the square root of 98, and that'll give you 7 root 2. So now we have it in the format that they want it in. So that's it for part C. Let's have a look at next question, question 3. Show that x is equal to 4 is a solution to the equation x squared minus 2x minus 8 is equal to 0. So we have x squared minus 2x minus 8 equal to 0. So all you've got to do to show that it's a solution is put 4 in instead of x. So we're going to put 4 in here, square it, put 4 in here, minus 8 equal to 0. So that'll give us 4 4 16. Minus 2 4s are 8, minus 8 equal to 0. 16 minus 8 is 8, 8 minus 8 is 0, so we get 0 is equal to 0. Therefore, x is equal to 4 is a solution. Okay, so that's part A. Part B, the equation x squared plus ax plus b is equal to 0, where a and b are integers, has solution x is equal to 5 and x is equal to minus 2. Find the value of a and the value of b. So what we're going to do here is we're going to look at x is equal to 5, and we're going to look at x is equal to minus 2. Now these are roots, so what I'm going to do is just convert them both to factors. So this here would mean then that x minus 5 is equal to 0 and x plus 2 is equal to 0. So these are factors. X minus 5 and x plus 2 are both factors. So what we do then is we just simply multiply those two together. That means that if we take the x minus 5, multiply it by the x plus 2, they should be equal to 0 when we multiply them. So let's multiply them out. So you multiply the x by the x, that's x squared. Multiply the x by the plus 2, that's plus 2x. Multiply the minus 5 by the x, that's minus 5x. Multiply the minus 5 by the plus 2, that's minus 10, and that's equal to 0. So simplify that then. We have x squared. Now we have plus 2x minus 5x, so that's minus 3x. Minus 10 equal to 0. So now we have it looking like this here. So we can just read off what a and b are. Well, a is what's in front of the x, it's the coefficient of the x, and we've got a minus 3 in front of the x, so a is minus 3. A is minus 3, so that means, let's see, b then is here, b must be minus 10. Okay, so let's have a look at the next part of this question. So we're going to look at part C. Find the solutions of 5x squared minus 2x minus 9 is equal to 0, where x is real. Give each answer correct to 2 decimal places. So again, this is a quadratic trinomial. So that just means that when they ask you to give it to 2 decimal places here, it means you're going to end up using the quadratic formula. So the quadratic formula is x is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. Now in this particular case, a is 5, b is minus 2, c is minus 9. So when we put this in here, we have minus b, so it's minus minus 2, which is plus 2. Plus or minus the square root of b squared, so that's minus 2 squared, minus 4 times a, which is 5, times c, which is minus 9. Put all of that over twice a, so twice 5. So these are our two answers, so we just need to sort all this out. So let's see, we have 2 plus or minus the square root of minus 2 squared is plus 4. Minus times minus, that's going to give me plus. So 4 5s are 20, and then we have 20 times 9, which is 180. Divide that by 2 5s, 10. So that's 2 plus or minus the square root of 4 plus 180, 184. So these are our two answers now. So we have 2 plus the square root of 184 over 10. Or 2 minus the square root of 184 over 10. So I'm just going to do these two, I think it was 2 decimal places they said. Give your answer correct to 2 decimal places. So what you got to do is type these into your calculator. So it's 2 plus the square root of 184 and then divide by 10. And to 2 decimal places, that's 1.56. So it's 1.5564 and so on. So that's actually 1.56 to 2 decimal places. On this side we've got 2 minus the square root of 184. That equals that there. Divide that by 10 and that gives us minus 1.1564. So it's minus 1.16 here to 2 decimal places. Okay. Let's move on then to the next question. So we have question 4. Solve the equation. So let's write it out. 4 times 2x plus 3 minus 7 is equal to 3 times x minus 5. So what we've got to do is multiply out the brackets first. So we have 2 4s are 8x plus 3 4s 12 minus 7. 3 times x, 3x minus 3 5s 15. So then just simplify both sides. On the left hand side we 8x. We've got 12 minus 7. So that's 5. Right hand side 3x minus 15. 15 here. Okay, so what I'm going to do now is subtract 3x from both sides. I'm going to bring this over here and I'm going to bring this over here. So I'm going to take minus 3x on this side and I'm going to take minus 3x on this side as well. Just do that first. So minus 3x on this side will give me 5x. That'll give me 5x. And on this side I'll end up with 0 there. Now plus 5 is equal to minus 15. Next thing I'm going to do is I'm just going to take this plus 5 and I'm going to subtract 5 from this side. So that will give me on the left hand side 5x, on the right hand side minus 20. Next thing I'm going to do, I want to get rid of this 5, so I'm going to divide by 5, divide by 5. So that'll get rid of it here. And that'll leave me with x here and minus 4 on this side here. Minus 4. Okay, so that's part A. Let's have a look at part B. Solve the simultaneous equations. Okay, so we have two equations here. Now we have a linear one and we have this one here with an x squared and a y squared. It's actually the equation of a circle. This is the equation of a straight line. So what I'm going to do, the way you're going to do this is do it by substitution. So you're going to take the linear equation, which is 2x minus y is equal to 7, and you're going to get x in terms of y or y in terms of x and substitute it into the second one here. So what I'm going to do is get y in terms of x. So what I'll do here is bring the 2x over to the other side. So I've got minus y is equal to minus 2x plus 7. So I've subtracted 2x from both sides. Now I'm just going to change this into a plus y. So in other words, multiply across by minus 1. That gives me 2x minus 7 here. So my y is equal to 2x minus 7. I'm going to substitute that in here and work it out. So we've got to substitute the 2x minus 7 into x squared plus y squared is equal to 49. So let's do that. So we have our x squared plus our y now is 2x minus 7, which we've got the square, and that's equal to 49. So let's just multiply this out. So we have x squared plus, now the 2x minus 7 squared is just going to be 2x minus 7 times 2x minus 7. So you've got to multiply that by that, that by that, that by that, and that by that. So the first thing we're going to do is just multiply 2x times 2x. So that's 4x squared. You can leave it in brackets if you like. We've got to multiply the 2x times the minus 7. So that's minus 14x. We've got to multiply the minus 7 by the 2x. So that's minus 14x. And then finally we've got to multiply the minus 7 by the minus 7. That's plus 49. And that's equal to 49 on this side. So we just need to simplify all of this. Let's see, we have, I put a bracket here if you like. It doesn't really matter. When you have a plus in front of the bracket, it doesn't really matter. We have an x squared plus 4x, so that'll give us 5x squared. We have a minus 14x, that's minus 28x. And then we have, let's see, we have a plus 49. I'm going to bring this over here, it'll give me minus 49. So that just gives me 0 there. So that will give me a 0 on this side, and the 49, these two 49s will cancel out if you like. So we have 5x squared minus 28 is equal to 0. So we've got to factorize this, so we have an x in common there, so I'm just going to take out the x, so that's 5x here, minus 28 is equal to 0. That will give me x is equal to 0, or 5x minus 28 is equal to 0. So that'll finally give me x is equal to 0, which we already have, or in this particular case you can just take 5x is equal to 28. X is equal to 28 divided by 5, so that's 5 5s, 5 6s, 5 5s, 5.6. Okay, so these are our two x's. So now we've got to work out what our two y's are. So the way you would do that is you would take maybe the linear equation here. It's usually the easier one to do. 2x minus y is equal to 7. So we have, let's take x is equal to 0 first. We have 2x minus y is equal to 7. We just substitute 0 in there. So if we substitute 0 in here for the x, we'll just get 0. So that'll give us minus y is equal to 7, or y is equal to minus 7. So our first answer would be x is equal to 0, y is equal to minus 7. If we take x is equal to 5.6, substitute it in, so that's 2 times 5.6 minus y is equal to 7. So that's 2 times 5.6, so that's 2 times 5.6, 11.2, minus y is equal to 7. That'll give us minus y is equal to, subtract 11.2 from both sides, so that's 7 minus 11.2. That'll give me minus 4.2. And finally that's y is equal to plus 4.2. Y is equal to plus 4.2. So my second answer here would be x is equal to 5.6, y is equal to 4.2. So they're my two answers. Let's see what we were asked. Just solve the simultaneous equations. So we've done that. We found that x can be 0 and y is minus 7, x is 5.6, and y is 4.2. Okay, question 5 then. The function f is defined as f of x is equal to 3x squared minus 6x plus 7, where x is an element of R. Find f of 0.67. So all you got to do is, instead of the x here, put in 0.67. It's going to be 3 times 0.67, which you've got to square, minus 6 times 0.67 plus 7. So you've got to do that then. So you've got 3 times 0.67 squared. So you take the 0.67 and you square that first, and then you multiply your answer by 3. And that gives you 1.3467. 1.3467. Now multiply 6 by 0.67. That is 4.02. And then add the 7. So just do all of that then. So you've got 1.3467 minus 4.02 plus 7. And that gives you 4.3267. 4.3267. So that's going to be approximately equal to 4.33, and that's to 2 decimal places, which is what we were asked here, 2 decimal places. Okay, find the value of x when f of x is equal to 4. So f of x here is just going to be equal to 4. So you write down 4 is equal to 3x squared minus 6x plus 7, and you've just got to solve this. So let's get rid of that 4 first. Subtract 4 from both sides. That's 3x squared minus 6x. Subtract 4 from 7, and you're left with 3 there. What you can do next here, I've just spotted here that you've got a 3 here, a 6 here, and a 3 here. So we can divide across by 3. So if we divide this by 3, that'll give us x squared. Divide 6 by 3, it'll give us 2, minus 2 there, and a 1 out here. Now, if we solve this, we can use our brackets, or you can use the quadratic formula, whatever way you want to do it. This is probably the easier way. X times x will give us x squared. 1 times 1 will give us 1. We want a plus 1. I'm going to multiply those two together to give us plus 1. So it's going to be plus plus or minus minus. Because this is a minus, it's going to be minus minus here. So So that means then that x minus 1 is equal to 0 or x minus 1 is equal to 0. So we're going to get the same answer here in both cases. X is equal to 1 or x is equal to 1. Now it says up here, find the value of x. Find the value of x. So our answer then, our answer is x is equal to 1 is our answer. Okay, so that's part B. Let's have a look at part C. Use calculus to find the coordinate of the local minimum point of f. The local minimum point of f. So let's write down f anyway. What is f? F is 3x squared minus 6x plus 7. So our f of x is 3x squared minus 6x plus 7. So we've got to use calculus to find the minimum. So what you do here is you find f prime x. So you got to differentiate this first. So bring the 2 down, multiply it by the 3, that's 6x. Subtract 1 from the power, so that's the power of 1. There's a 1 up here. Bring it down, multiply it by the minus 6. Subtract 1 from the power, so that'll give us x to the power of 0, which is just 1. So this is our differential. This is what we get when we differentiate this function here. So we want to find the local minimum point. Now remember, this thing here, this f of x, is a quadratic, and it's going to look like this. It's a parabola. So it has a minimum point down here somewhere. We've got to find the coordinates of that point. We've got to find what the x and y values are. So the way you do that is you take your differential 6x minus 6, you let it equal to 0, because this gives you the slope of any tangent around here. It gives you the slope. So if you take this tangent here at the very bottom, that has a slope of 0 because it's horizontal. So we let the slope equal to 0 here, and we just solve that. So you get 6x is equal to 6. Bring that over here, or so add 6 to both sides, and then just solve for x, then divide by 6. So you get x is equal to 1. So now we know that our x coordinate here is 1. Now in order to find the y coordinate, what you do is you go back to your original function and put the 1 in there. So we want f of 1. So f of 1 is going to be 3 times 1 squared minus 6 times 1 plus 7. That's 3 ones are 3. The 1 squared is just 1. Multiplied by 1 you get 3. Minus 6 plus 7. That gives 3 minus 6 is minus 3. Minus 3 plus 7 plus 4. So our coordinates are 1 and 4. So our answer just says find the coordinates of the local minimum point. So the answer is 1, 4. Okay, so that's part C. Let's have a look at, that's actually that question finished, so let's have a look at question 6. Find k. Okay, so we have the first 3 terms of an arithmetic sequence, which are minus 5, k, and 1. Find k and hence or otherwise show that the common difference is 3. So we have minus 5, we have k, and we have 1. Now there's a couple of ways of doing this. You can probably spot what k is going to be, and you can probably show that the difference is 3 then after that. But you can maybe do it this way. If you take the difference between these two and the difference between these two, they should be equal. So in other words, if you take k minus minus 5, it should be exactly the same as 1 minus k. 1 minus k. Because we're told that it's an arithmetic sequence. In other words, the difference between these two should be exactly the same as the difference between these two. So k minus minus 5 is k plus 5. It's equal to 1 minus k on this side. So if we take this k here and bring it over to the other side, that'll give us 2k. And then bring the 5 over, subtract 5 from both sides. So we have 0 on this side, but we have 1 minus 5 on this side, which is 1 minus 5 is minus 4. That'll give us k is equal to minus 2. Divide by 2, divide by 2. So k is minus 2. So if k is minus 2, we have minus 5, minus 2, 1. So if you have a look at the difference then, how do you go from minus 5 to minus 2? How do you go from minus 2 up to 1? You're adding 3 each time. So we're adding 3 adding 3. So common difference here is 3. Find k. Well, we found k. Hence or otherwise show that the common difference is 3. So this is showing it here if you like, or you can do it out in a little bit more detail. You can take minus 2 minus minus 5. That gives you minus 2 plus 5, which is 3 plus 3. So that's our common difference, which is D. You could also do 1 minus minus 2. That will also give you 3. So that's it really for part 1. Let's have a look at part 2. Find Tn, the 10th term in the sequence. So we have minus 5, we have minus 2, and we have 1. We know we're adding 3 each time, so you could just work this out. We don't have to go up too many, it's only 10. So we could just keep adding 3. So that would give us 4 here, 4, 5, 6, 7, 8, 9, 10, 13, 16, 17, 18, 19. How many have we gone up? 1, 2, 3, 4, 5, 6, 7, 8, 9. And then finally add 3 to 19. You get 22. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 22, that's T10. So T10 is equal to 22. That's our answer there. Find which term in this sequence has a value of 247. Okay, so we're going to need to work on our formula at this stage, I think. So if you look up your maths tables, you see there's a formula in there for arithmetic sequences to find any term number, and it's a plus n minus 1 times d. Now Tn in our particular case is going to be a, which is the first term, and you can see here that our first term is minus 5. So we're going to put in minus 5 here, n minus 1. Our common difference is 3. So the formula that's going to work for our particular sequence is going to be 3 times n here, 3 times minus 1 minus 3. So it's going to be minus 5 minus 3 minus 8 plus 3n. This is our formula here. Now we want to find out what the n value is, the term in the sequence that has a value of 247. So 247 is going to be out here. We just got to work backwards to find what n is. So I'm going to add 8 to both sides. So that will give me 255 here. That's 3n. And then divide by 3. So let's see, 3 8's 24, 3 5. So it's going to be 85. 85. So that means our answer here is it says which term in the sequence has a value of 247. So it's going to be term 85. Okay, so part B, the first 3 terms of a different arithmetic sequence are 4, 9, and 14. Find S50, the sum of the first 50 terms. So again, if you look up your log tables, you've got Sn is equal to n over 2 times 2a plus n minus 1 times d. So we've just got to put in our n's and d's here and so on. We want S50, the 50th term. So that means n is 50, so we're going to put 50 here. Our first term is a here, which is 4, so we've got to multiply that by 4. N is 50, this is 50 minus 1, which is 49. And our common difference here is, well, 4 up to 9 will give you 5. 9 plus 5 will give you 14, so our D is 5. So this is what we've got to work out. So we have 25 here, 50 divided by 2 is 25. 2 4s 8, plus 5 times 49 is 245. And then we just got to do that, add 8, and then multiply our answer by 25. That gives us 6325, 6325 here. Okay, so that's part B. Okay, so now we're into question 7. So these are the longer type questions here. let's see, the rates and thresholds of the universal social charge, the USC in Ireland, excluding the top rate. So they give us the three rates here, but they don't give us the top rate, the percentage there. During 2020 are given in the table below. So for the first 12,012 euros that you earn, you've got to pay 5%, 0.5% on that. For the next 8,472 euros, you've got to pay 2%. And then for the next 49,560 euros, you've got to pay 4.5% on that. Whatever's left over then, after you add these three up here that you earn, you've got to pay some other rate which we're not given. At what level of annual income does a worker start paying the top rate of USC? So the top rate. So really what you've got to do here is you've got to add these three up. So you've got to take your 12,012 plus 8,472 plus 4,9,560. You've got to add those three up. So let's do that. That gives us 70,044. So that's 70,044 euros. That's our answer there. Okay, so how much USC will a worker have paid in total if they pay the maximum amount due at each of the first three rates? So in other words, if someone earns this amount here, how much USC will they actually pay? So you've got to get 0.5% of 12,012. You've got to get 2% of 8,472, and you've got to get 4.5% of 4,9,560. So I'm going to work each of those out and then add them up. So let's do that. I'm going to add these three up. So the total then, total USC is going to be that plus 169.44 plus 60.06. That's a total of 2459.7. 2459.70. So how much USC will a worker have paid in total if they pay the maximum amount due at each level, the first three rates? So this is the amount you're going to pay in USC if you don't pay, if you just about reach this level here. Okay, so John's annual income is 54,800. Find the amount of USC he will pay. We see from part A here, it says at what level of income does a worker start paying the top rate? That's at 70,044. Now John is paying less than that. So he's paying 54,800, or he's earning 54,800. So he's not going to reach the top rate. He's only going to be paying these three here. So let's work that out. So we know that he's going to pay the first one. So we know that he's going to pay 0.5% of 12,012, and we know that that's 60.06. We've worked that out here. We know that he's going to pay another 2% of 8,472. That's 169.44. So what's left over then? If we add those two up, so it's 12012 plus 8472, that's 20,484. So if we take his income, which is 54,800, subtract 2484, that means he's got to pay the 4.5% on 34,316 euros. So in other words, he's got to pay the 4.5% of what's left, which is this amount here, 34,316. So if you multiply that by 0.045, that'll give us 1544.22. So his USC, USC will come to 1773 1773.72 euros. This is the amount of USC that John will have to pay. Okay, so that's it. Let's have a look at part D. Mary pays 1,602 euros and 72 cents in USC in 2020. Find her annual income. Find her annual income. Okay, so what we've got to do here is just look at the amounts that of USC that you will have to pay. If you pay the full amount here, you're going to pay 60 euros and 6 cents here. You're going to pay 169.44 euros there. You're going to pay 2,230.2 euros at the top rate here, 4.5%. So this is the maximum amount of USC that you're going to pay if you don't reach the top rate. So she is paying 1,602, so she's paying less than this, which means she's paying these two in full, and then she's not quite paying the full amount here. So we know that she's going to pay these two here, so let's just add those two first. So it's 60.06 plus 169.44. So we're going to add those two first. So we're going to take 60.06 and we're going to add 169.44. If you add those two, you get 229.50. So that's what she's going to pay at the first two rates. Now the third rate, then we're going to take our 1602.72, subtract 229.50. That means at the higher rate, then at the 4.5% rate, she has paid 1373.22. So in other words, 1373.22, that's going to be equivalent to 4.5% of her salary at this particular level, 4.5% level. So we want 1%. So you got to divide by 4.5 and then go up to 100%, which will give us 30,516 euros. So you divide by 4.5 and multiply by 100. Now this is the amount that she's earning. This is the amount that she's earning at this level here. At this level here. So what we've got to do is add these two amounts. So we're going to take the 30,516, add the 12,012, and add 8,472. When you do that, you get 51,000 euros exactly. So that's her total salary. Okay, so that one's kind of a tricky little one, but let's move on. We have part E. Patrick has an annual income of 83,000 and pays a total of 3,496.18 euros in USC. Find the top rate of USC. Okay, so find the top rate. So these three added up again. Let's just add those up. So you got 60, maybe I have it up here already, do I? I do. 2459.70. 2459.70. Now you didn't have to write all this out again, but this is what he's going to pay at the first three rates. We've got to work out the top rate. So we know that he pays this amount here in total. So the amount that he pays at the top rate then is going to be 3496.18 minus 2459.70, paying 1036.48 euros. So he's paying 1036.48 euros at the top rate. So that's what he's paying at the top rate. Now he's paying that on the difference between these three added and this here. So it's going to be 83,000. You got to subtract these three added. So when you add those three again, 0.044. So if you subtract those two, 83,000 minus 70,044, that gives you 12,956. 12,956. So he is paying the top rate on this amount here, and this is what he's actually ends up paying. We take the 1036.48 divided by 12,956, multiply by 100 to give us our percentage, and let's see what we get, and that gives us 8%. 8%. So the top rate is 8%. Okay, so that's it for that question. Let's have a look at question 8. A square sheet of cardboard of side 10 units is used to make an open box. Squares of side x units, where x is real, are removed from each corner of the cardboard, and it is then folded along the dotted line as shown in the diagram below in order to create the box. The length, breadth and height of the box are shown in the diagram above. Write L, B and H in terms of x. So if you take your original square sheet, it's square, so that means it's 10 this way, it's 10 this way as well. So and the length and the breadth are just going to be 10 minus 2x. You have an x here, you've got an x here, total in 10, so you're going to take this distance from here to here is just going to be 10 minus 2x. So the length is going to be 10 minus 2x. The breadth here is also going to be 10 minus 2x, and then the height up along here is just going to be an x. That's just going to be your x there. We've got to work out the volume of the box. We've got to show that the volume of the box can be written like this. So the volume of a box, the volume is just going to be length times width times height. So that's just going to be 10 minus 2x times 10 minus 2x times x. So let's do that. We've got, I'll just do these two first, okay, the two brackets first. So 10 times 10, 100. 10 times minus 2x, minus 20x. This one here, another minus 20x. And then these two here, plus 4x squared. Then we've got to multiply all of that by x. So if you do that, you get 100x. Minus these two here give you minus 40x, and then multiply it by the x, you get minus 40x squared. Then we got plus 4x cubed here. Now is that what they're looking for here? I think it might be. Let's see. So the volume v of x then is just going to be equal to, I put the 4x cubed first, so 4x cubed, then they've got the x squared next, so it's going to be minus 40x squared, and then the plus 10x out here at the end. Explain why a box of height 6 units cannot be made from a sheet of cardboard. 6 units, well, if you take the length or the width, so the length, let's say, is equal to 10 minus 2x, I think it is, isn't it? 10 minus 2x. If x is equal to 6 units, that would mean then that the length is equal to 10 minus 2 times 6, which is equal to 10 minus 12, which is equal to minus 2 units. And length cannot be negative. And that's it. Okay, let's have a look at D. So in D here we've got to complete the table below to show the value of v of x is equal to 4x cubed minus 40x squared plus 100x, where x is real, for a given value of x in the domain x between 0 and 5. So a couple of ways of doing this. I mean, you can do this thing manually, or you can put it into your calculator and your calculator will work it out for you. You use the table function and put the function in between 0 and 5, step it up in 0.5s, and it'll just complete the table for you. So I've done this already, so I'm just going to put in the values that I got. So if you put 0 in, you're going to get 0. Put 0.5 in, it's given already. Put the next one in here, 1, you get 64. 73.5. 72. 2.5 is 62.5. 3 is 48. 3.5, 31.5. 4 is 16. 4.5 is 4.5, and 5 is 0. Now, just to show you how this might be done manually, you would take the 4x cubed minus 40x squared plus 100x, and let's pick a number here. Let's pick 2, for example. You just put the 2 in. So you would put 2 in here, cube it, 40 times 2, square it, plus 100 times 2. You would work that out. Make sure you do the powers first here. So that's 2 2s are 4, 2 4s are 8, 4 8s 32, 2 2s are 4, 160 here, and then plus 200. That'll give you 32 minus 160, 32 minus 160 plus 200, and that gives you 72 when you do that, okay? 72. And that's what we got here. Okay, so let's move on again. Okay, so next thing we've got to do is draw the graph of the function on the grid below. So what we're going to do here is just plot all these points. So let's take the first one here, which is just 0 0. So we're going to put in 0 0 here. Next one is 0.5, 40.5. So 0.5, 40.5, that's going to go here. Next one is 164, so 1 and 64 is around there somewhere. Then we've got 1.5, 73.5. 73.5 is going to be around here. 2 is 72, so we've got to go around here. 2.5, 62.5. 62.5 is going to be around here. 3 is 48. So let's go to 48, which is around here. 3.5 is 31.5. 31.5, so that's around here somewhere. 4 is 16. And 4.5 is 4.5. And 5 is 0. So it kind of tails off there at the end. So you got to join all this up. So just join it up as best you can. It should curve at the top. And then come down again. Okay, this is not a point here. Now, so that's our graph. Use your graph to estimate each of the following values, the maximum volume of the box. Well, volume here is on the y-axis, so we've got to find the maximum volume of the box. So maximum volume is going to be here, so we're just going to come over this way. You guys need to use a ruler here. I don't have a ruler, so it's around there. So I'm going to say 74. 74. And it's unit squared there. Now, second one is the value of x that will create a box which has a volume of 30 units. 30 units. So we've got x along the x-axis. So 30 units is going to be here. So we've got to come across. Just use a different one here, I think. 70 units squared there. So we're going to take 30. So 30 is here, so I'm just going to come across and down here, and then across here, and down here. So the values of x, two values here. So we've got, I'm going to say 0.35, 30, let me just see. I'm going to say 3.6 here, actually, 3.6. Okay, so next thing we've got to do is find the volume of the box when x is 2.8. So if x is 2.8, so 2.8 is going to be somewhere, it's 2, 2.5, 2.75, 2.8 is going to be around here. So I'm going to come up along here like this. Again, you guys need to use a ruler, otherwise this kind of thing will happen. So we're up along here and then across. So I'm going to say 54 here, 54. If you use a ruler, it'll be a lot more accurate anyway. 54, and you should be allowed a certain tolerance around these as well in the exam, because different people will draw graphs in different ways. Okay, so let's have a look at question 9 then. Question 9, the first 3 patterns in a sequence of patterns containing dots and crosses are shown below. So we got 1 dot and 1 cross, 2 dots and 4 crosses, and so on. Draw the 4th pattern in the sequence into the box below. So we're going to have 1, 2, 3, 4. Then we're going to have 1, 2, 3, 4, and then along here we're going to have 1, 2, 3, 4. So it should look something like that. Okay, so easy marks there. Find a formula in n for the number of dots in the pattern n. So we have 1 dot, if you take this as being T1, T2, T3. So it's 1 dot for T1, 2 dots for T2, 3 dots for T3. So it's just simply going to be Tn is equal to n. Find a formula in n for the number of dots in pattern n of the sequence Tn. Okay, so find the total number of dots in the first 20 patterns in the sequence. So really that's just going to be if Tn is equal to n, what we've really just got to do is add up 1 plus 2 plus 3 plus 4 plus 5 all the way up to 20. Your Sn is going to be n over 2. You can do it this way either, n over 2, 2a plus n minus 1 times d. So n, we want the sum of the first 20. So it's going to be 20 over 2 times twice the first one, which is just 1. A is the first term. N minus 1 is 19, and the difference is just 1. If you're going 1, 2, 3, 4, 5, 6, 7 up to 20, the difference is just 1. So here we've got 10 times 2 plus 19. So that's just going to be 19, 20, 21. Multiplied by 10 is 210. So the sum of the first 20 terms is just going to be 210. You could have just added that up on your calculator, 1 plus 2 plus 3 plus 4, all the way up to 20. The table shows the number of crosses for the first 2 patterns. Complete the table and hence find a formula for the number of crosses in pattern n of the sequence. So in the first pattern we have 1 cross. In the second one we've got 4. In the third one you'll find you'll have 9. In the fourth you'll have 16, 25, 36. The number of crosses in pattern n, really you should find that it's just n squared. Really what you're doing is you're taking 1 squaring it, 2 squaring it, 3 squaring it to find the number of crosses in each. So that's it. Let's see, find the number of crosses in pattern 12 of the sequence. So we know that Tn is equal to n squared in this particular case. So we want the number of crosses in pattern number 12. So it's just going to be 12 squared, which is 144. 144. And that's it really. Let's have a look at number 6. Find the number of shapes, dots and crosses in pattern 10. Well, if we add the two together, our Tn is going to be n plus n squared. This is the number of dots, this is the number of crosses. So we want T10, so it's going to be 10 plus 10 squared. So that's just going to give us 10 plus 100, which is 110. And that's it there. The first two patterns in a sequence of patterns of crosses are shown below, pattern 1 and pattern 2. Okay, the number of crosses in pattern n is Tn. The general term for describing Tn can be written like this here. Tn is equal to n squared over 2 plus bn plus c. Use substitution for n to write T1 and T2 in terms of b and c. So T1 is going to be 1 squared over 2 plus b times 1 plus c. So that's just a half plus b plus c. T2 then, you just put in 2 for n. So it's going to be 2 squared over 2 plus b times 2 plus c. So that's 2 2s are 4. 4 divided by 2 is 2 plus 2b plus c. And that's it. Let's have a look at part 2. Hence or otherwise, find the value of b and the value of c. So really what you've got to do here is simultaneous equations here, okay? Okay, so we have half plus b plus c. That's term number 1. How many items are in term number 1? We've just got one of them. So that's going to be equal to 1. What about the second one? We have 2 plus 2b plus c. How many are in that? We've got 3 of them. 3 things in pattern number 2. So that's going to be equal to 3. Let's just change those around a little bit. I don't like fractions, so I'm going to get rid of this fraction. I'm going to multiply across by 2. So that will give me 1 plus 2b plus 2c is equal to 2. Or that will just give me 2b plus 2c is equal to 1 when I bring that over here. Now that's equation number 1. So this is equation number 1 here. Let's have a look at equation number 2. All I'm going to do with equation number 2 is bring that 2 over here. Subtract 2 from both sides. So that will give me 2b plus c is equal to 1. This is equation number 2. Now if you have a look at those two, what I'm going to do is take the first equation, this one here, and I'm going to multiply it by minus 1. So I'm going to take equation 1 and I'm going to multiply it by minus 1. If I do that, I'll get minus 2b minus 2c is equal to minus 1. That will give me this. If I add these two equations now, 0 here, I'll get minus c here, and I'll get 0 here. So that will give me c is equal to 0. So let's find b. So that's 1 now. I've found c. Let's see if we can find b. So take one of the equations. Let's take 2b plus c is equal to 1. That's equation number 2. And just substitute in 0. Just substitute in 0. So we've got 2b plus 0 for c is equal to 1. That gives you 2b is equal to 1. That gives you b is equal to a half. So now we have b as well. So there's b. So we have b is equal to a half and c is equal to 0. That's it. That's actually it for that question. Let's have a look at the last one then, question 10. The water behind a dam is normally released at a rate of 250,000 litres per second. Find how long it takes to release 1 million cubic meters, 100,000 or 1 million cubic meters of water. Note that 1 cubic meter is 1,000 litres. Give your answer correct to the nearest minute. Now if you take your 250,000 litres and just convert that to cubic meters, let's have a look at that. We know that 1 cubic meter is 1,000 litres, so we just divide by 1,000, so it's 250 cubic meters. 250 cubic meters is 250,000 litres. What have we got to do? Find how long it takes to release 1 million cubic meters. So the water is released at a rate of this many 250 cubic meters every second. So we want to know how long is it going to take to release 1 million cubic meters. So all we got to do is take the 1 million. 1, 2, 3, 4, 5, 6 zeros. We got to divide that by 250. So let's have a look at that. 1,000,000 divided by 250. So it's going to take 4,000 seconds. What do we have to give it to? The nearest minute. We want to give it to the nearest minute. So we've got to convert 4,000 seconds into minutes. So we're going to divide by 60, and that will give us 66.666, so 66 and 2/3 minutes. So that is to the nearest minute, that's going to be 67 minutes. Okay, so that's the first part. Let's have a look at the second part then. Due to a heavy rainfall, the operators of a dam decide to increase the flow by 10% for 24 hours. Find how many cubic meters of water were released in that 24-hour period. Give your answer in the form scientific notation. Give the value of A correct to 3 significant figures. So they're going to increase the flow by 10% for 24 hours. So the current flow rate is 250 meters per second. We want to increase that by 10%. So you've got to get 10% of 250, which is 25. So we want to increase that. So you've got to take your 250, add 25. So that's 275 cubic meters per second. That's the new flow rate, if you like. So find how many cubic meters of water were released in that 24-hour period. So they're releasing 275 cubic meters every second. So 275 cubic meters every second. Every minute we got to multiply it by 60. Every hour then you got to multiply it by another 60. And then multiply it by 24 because there are 24 hours. Well, we're talking about a 24-hour period anyway, so they say 24 hours up here. So let's have a look at that. 275, we got to multiply it by 60 to convert it to minutes. Multiply it by another 60 to convert to 2 hours. Multiply it by 24 for 24 hours, and we get 2376 with 4 zeros after it, and that's how many cubic meters were released. So that's meters cubed. So we've got to give our answer in scientific notation. So we've got to write that in scientific notation. So the decimal point is out here. So what we got to do is bring that decimal point back here to make a number between 1 and 10. A has to be between 1 and 10. So 2.376. Now to bring it back again to here, we got to multiply by 1, 2, 3, 4, 5, 6, 7. We got to multiply by 10 to the power of 7. This is our answer here. 2.376 by 10 to the power of 7. Now we got to read the question again. It says, give your answer correct to 3 significant figures. We have 4 significant figures there. So this is going to be equal to 2.38. So your significant figures start here. And 3 significant figures are going to be here. This is a 6, so we've got to change this to, got to round that up to 8. So that's by 10 to the power of 7 here, meters cubed. That's it for part 2. Let's have a look at part B then. John walks around a circular trail of radius 0.5 kilometers at a steady speed of 6 kilometers per hour. How long will it take him to complete 3 full circuits of the trail? Give your answer correct to the nearest minute. The radius here is 0.5. He's walking at 6 kilometers per hour, and he's going to do three circuits of this circle. So what we've got to do here is work out how far it is to walk around one circle. So the circumference of a circle is 2 pi r. 2 pi r. Now we have 2, we got to multiply it by pi, and then we got to multiply it by 0.5. So that's going to be 1. 2 times 0.5 is 1. 1 times pi is pi. So it's that many, it's pi kilometers, if you like. So pi is 3.1415 and so on. So it's roughly 3 kilometers around. So he's doing that at a pace of, let's see, 6 kilometers every hour. So we've got to work out how long it takes him to do it. So remember, speed is distance over time, or you can do your dad's silly triangle here. So you've got distance here, you've got speed here, you've got time here, and you're multiplying these two. So we want let's see, how long will it take? How long will it take? That's time. So we want time here. So time is distance over speed. So in our particular case here, we're going to have a distance of, he completes 3 full circuits, so he completes 3 pi in total, and his speed is 6. So that's going to be pi over 2, pi divided by 2, or 3 pi over 6. You can do that on your calculator anyway. So multiply pi by 3, and then divide your answer by 6, and that gives you half pi. Change that, and you get 1.5707. So this is 1.57079, and so on. Now this is hours, because remember we were talking about kilometers per hour up here. It says here, give your answer correct to the nearest minute, so we got to convert this to minutes. So that's going to be equal to, you got to multiply that by 60, and that gives you 94.2477 and so on minutes. Now we want it to the nearest minute, so that's going to be 94 minutes to the nearest minute. And that's it for that one. So let's move on to the second part. So we have Mary decides to walk every day over a 5-day period. She walks a distance of 3 kilometers on day 1. She increases the length of her walk by 15% each day for the next 4 days. Her average speed on day 5 is 4 kilometers per hour. Find how long it takes her to complete her walk on day 5. Give your answer in minutes. Okay, so Mary decides to walk every day over a 5-day period. She walks a distance of 3 kilometers on day 1. So this is day 1. So if we put in day 1 here, and the distance here in kilometers, so this would be 3 kilometers. So on day 2 she's increasing that by 15%. So you would take the 3 and multiply it by, you can get 15% and add it on, or you can take it, multiply it by 1.15. So you take the 3, multiply it by 1.15, that will give you 3.45. On day 3 then, again, multiply that there by 1.15, or you can get 15% of it and add it on. That gives us 3.9675. On day 4, multiply that by 1.15 again. That's getting bigger now, so let's see, 4.562625, and on day 5 then multiply that by 1.15. That gives you 5.24701.875. I don't think we need that many decimal places, but that's the distance that she does in kilometers on day 5. Now her average speed on day 5 is 4 kilometers per hour. Find how long it takes to complete her walk on day 5. Now again, from our little triangle up here, we know that time is distance over speed. So time is distance over speed. So the distance she's walking is 5.24701.875. We've got to divide that by her speed. Her average speed on day 5 is 4 kilometers per hour, so we've got to divide that by 4. So we're going to take that amount there. Let's see, 5.24701.875 divided by 4, and that gives me 1.311754688, and this is hours because we used kilometers and we use kilometers per hour up here. So this is hours, and we've got to give our answer in minutes correct to the nearest minute. So this is going to be equal to, we've got to multiply that by 60, and that will give us 78.7. So that's 79 minutes to the nearest minute. And that's it. Okay, next one. One day during John's walk, he meets Mary at point P. Mary is walking in the opposite direction at a steady speed of 4 kilometers per hour. John continues walking at 6 kilometers per hour. How far will he travel until he meets Mary again? Give your answer correct to the nearest meter. Okay, so we're going to look at distance here. So distance is speed. Let's see, we have speed is distance over time. So distance then is going to be equal to speed times time. Speed times time. We know that they're going to walk in this direction and this direction here. Now when they meet again, their total distance, the total distance between the two of them should equal pi. Remember back up here we worked out that the distance around the trail here is pi kilometers. So when they meet, their total distance should equal to pi. So the distance that Mary is going to travel at a speed of 4 kilometers per hour. 4 kilometers per hour. And let's take the time that it takes her to meet John, let's say t. So if we take that and we add John's distance, let's see, John is walking at 6 kilometers per hour, so it's going to be 6 times t. Remember, it's going to be the same time, and that should equal to pi. So let's work out the time then that it takes the two of them to meet. So let's see, 4t plus 6t, this is going to be 4t here, this is going to be 6t is equal to pi. That'll give us 10t is equal to pi. That'll give us a time is equal to pi over 10. So and that is in hours again. This is hours. So we have the time it's going to take the two of them before they meet down here somewhere. So what have we got to actually do? Find how far will he travel until he meets Mary. So we've got to find the distance John is traveling. Now distance is speed times time. So John is walking at 6 kilometers per hour. So we want distance is equal to speed times time. So remember the speed is 6. The time we worked out as pi over 10. So let's just multiply all that out. So you've got 6 times pi, and then we've got to divide that by 10. We've got to change that, so it's 1.884955 and so on. This is in kilometers. So what do we want? Give your answer correct to the nearest meter. So if that's in kilometers, we've got to change that to meters. So we've got to multiply by 1,000, which will stop there. So our answer will be 1.1885 meters. Okay, and that's it for this question and actually this paper.